There is a specific awkward brand of silence that occurs in the world of international arms dealing when a customer suddenly decides they don't need the rest of the order because they've figured out how to build a better version themselves. For the Russian aviation industry, that silence arrived in 2004. After years of supplying Su-27SK kits to Shenyang for local assembly under the J-11A designation, the Kremlin's representatives were told that the remaining 95 aircraft on the contract were no longer required. The reason given was politely bureaucratic. The Su-27SK no longer met the requirements of the People's Liberation Army Air Force. In reality, China had spent the previous decade performing a masterclass in reverse engineering, digital integration, and industrial espionage, and they were finally ready to unveil the J-11B. To the casual observer, it looked like just another flanker, that gorgeous swan-necked predator that had dominated the imagination of the late Cold War. But beneath that familiar titanium skin, the J-11B represented a fundamental shift in the tectonic plates of global air power. It was the moment the student decided the teacher was obsolete. To understand why the J-11B is perhaps the most significant fighter in the modern Chinese inventory, you have to appreciate just how desperate the situation was for the PLAF in the early 1990s. While the West was marveling at the stealth of the F-117 and the sensor fusion of the burgeoning Advanced Tactical Fighter program, China was largely defended by thousands of J-6 and J-7s, essentially polished versions of 1950s Soviet technology. When they finally got their hands on the Su-27, it wasn't just an upgrade, it was like handing a smartphone to someone who had only ever seen a rotary dial. The flanker brought range, a massive radar, and the kind of aerodynamic sorcery that made Western pilots break out in a cold sweat during airshow maneuvers like the Pugachev's Cobra. But as much as the Chinese loved the airframe, they were deeply unimpressed by what was inside it. The Russian avionics were heavy, the cockpit was a dizzying clock shop of analog dials, and the integration was so rigid that the aircraft could only use specific Russian-made missiles. The J-11B was the ambitious, slightly arrogant attempt to take that world-class Russian body and give it a Chinese brain, heart, and nervous system. This project was a massive gamble. It wasn't just about copying a blueprint. It was about reinventing the manufacturing process of one of the most complex machines ever built. The original Su-27 used a lot of heavy steel and titanium alloys, reflecting a Soviet philosophy that prioritized ease of repair and structural ruggedness over weight optimization. The engineers at Shenyang looked at those massive airframe components and saw an opportunity. They decided to replace large portions of the secondary structure and even some primary load-bearing elements with domestic carbon fiber composites. This wasn't just a weight-saving exercise, it was a test of China's entire material science industry. By shedding several hundred kilograms, they could improve the thrust-to-weight ratio and extend the airframe life, two perennial weaknesses of the original Soviet design. If deep dives into the strategic and technical decisions behind modern fighters interest you, subscribe. There are plenty more aircraft worth examining closely. The B in J-11B truly stands for a departure from the A model's kit-built limitations. When you climb into the cockpit of an original Su-27, you are stepping back into the 1970s. It is a masterpiece of ergonomic confusion, designed for a pilot who is expected to be a mere extension of a ground-controlled intercept station. The J-11B threw that philosophy in the trash. In its place, Shenyang installed a modern glass cockpit featuring 5 large multifunction color displays. It sounds like a small thing, but for a pilot, the difference is existential. Instead of cross-referencing 10 different needles to understand their fuel state and engine health, they have unified, intuitive graphics. More importantly, the Chinese replaced the antiquated Russian NO-001 radar with the domestic Type 1474, often referred to in export literature as the KLJ-4 pulse Doppler set. While the Roundabout was a powerful beast, it was an analog dinosaur that was notoriously difficult to maintain and easy to jam. The Type 1474 gave the J-11B the ability to track more targets at longer ranges, reportedly over 150 kilometers for fighter-sized targets, and crucially, provided the digital backbone required to fire China's new generation of active radar-guided missiles. This digital backbone is where the J-11B really began to outpace its Russian ancestor. The original Su-27 was hardwired for the R-27, a semi-active missile that required the pilot to keep the radar locked on the target until impact, a suicidal requirement in a modern dogfight where staying pointed at the enemy means you are flying directly into their return fire. The J-11B was designed from the outset to carry the PL-12, China's answer to the American AIM-120 AMRAAM. This fire-and-forget capability transformed the flanker from a high-performance interceptor into a true multi-role threat. Once the PL-12 goes active or pitbull, the J-11B pilot can turn away or crank, maximizing the distance between themselves and the enemy. The integration of a domestic data link, known as the Joint Information Distribution System, JIDS, also meant that J-11Bs could talk to each other and to Chinese AWACS aircraft, sharing a common picture of the battlefield. The Russians eventually achieved this level of networking with the Su-30 and Su-35, but for a period in the late 2000s, the Chinese J-11B was arguably a more digitally capable air superiority fighter than the standard Su-27s sitting on Russian tarmacs. However, the most controversial and difficult part of the J-11B's development was its heart, the WS-10 Taihang turbofan. If you want to see an aerospace engineer look tired, ask them about domestic jet engine development in China during the early 2000s. For decades, this was the Great Wall of Chinese aviation. You can copy a wing shape or a radar circuit relatively easily, but you cannot simply copy the metallurgy and precision manufacturing required to keep a turbine spinning at 15,000 RPM while bathed in gases hot enough to melt steel. The decision to use the WS-10 instead of the reliable Russian AL-31F was a statement of national sovereignty. But for the first few years, it looked like a catastrophic mistake. The WS-10 was not a direct clone of the Russian engine. Its core was heavily influenced by the CFM56 commercial engine, which itself shares heritage with the General Electric F101 and F110. This meant the Chinese were trying to marry a Western-style high-pressure core with a Russian-style airframe, a Frankensteinian integration challenge that led to severe airflow compatibility issues. Early WS-10s were notoriously unreliable, with some reports suggesting an on-wing life of only 30 to 40 hours before requiring a total overhaul. There were stories of engines vibrating so violently they threatened to shake the airframe apart, and more than one J-11B was forced into an emergency landing when its Taihang decided it had had enough of atmospheric flight. The primary failure mode was the turbine blades. The high operating temperatures required for the engine's thrust targets demanded single crystal turbine blades, a technology China struggled to master. Early blades made from directionally solidified alloys would deform or crack under the thermal stress, sometimes leading to spraying, a terrifying event where the engine ejects molten metal out the back. Despite these teething problems, a polite term for an engine that occasionally tries to explode, the Chinese stuck with it. They had to. If the J-11B was going to be the backbone of their Air Force, they couldn't be reliant on Moscow for spare parts every time a tension rose in the Taiwan Strait. The engineers at Liming worked tirelessly on the WS-10, iterating through version after version, improving the rhenium-nickel superalloys and the digital engine controls. By the time the J-11B reached full-rate production with the WS-10B variant, the engine had matured into a respectable, if not world-beating, power plant. It actually produces slightly more thrust than the original Russian AL-31F, around 132 kN in afterburner, and when combined with the J-11B's lighter, composite-heavy airframe, it gives the aircraft a noticeably punchier performance in a climb. It's the kind of brute force that makes the flanker's massive internal fuel load and 12 weapon hardpoints feel less like a burden and more like a threat. Visually, the J-11B is distinguished from its Russian cousins by a few subtle but telling details that serve as a field guide for the observant enthusiast. The most obvious is the radar dome. While early models and the original Su-27s had gray or white radomes, the standard J-11B features a distinctive black dielectric panel on the nose. More telling are the wingtip pylons. The Russian Su-27 carries the R-73 missile on a simple, flat rail. The J-11B, however, uses a stepped pylon shape. This is necessary to accommodate the large, boxy fins of the PL-8 missile, a licensed copy of the Israeli Python III. This integration required structural reinforcement of the wings, as the PL-8 is significantly heavier and draggier than the Russian missile it replaced. You will also notice the presence of ultraviolet missile approach warning system, MAWS, sensors located on the tail boom and behind the cockpit. Little glassy eyes that were absent on the original Su-27SK. The engine nozzles on the WS-10 equipped aircraft are also shorter and feature petals that are visibly different from the longer, smoother cans of the Russian AL-31F. It's a fascinating bit of hybrid vigor, a Soviet aerodynamic design, lightened by Chinese composites, powered by a domestic engine with American DNA, guided by Israeli-derived short-range missiles and carrying American-style long-range active radar missiles. It is the physical manifestation of China's absorb and improve strategy. The shift to composites and new avionics also had a profound effect on the aircraft's center of gravity. The Su-27 is a statically unstable aircraft, meaning it wants to flip over and fly tail first, a tendency kept in check by the flight control computer. By removing nearly 700 kilograms of weight, much of it from the heavy analog avionics in the nose and the metal structures in the wings, the Shenyang engineers inadvertently messed with this delicate balance. To compensate, they actually had to install ballast counterweights in the nose cone of the early J-11B variants to restore the longitudinal static margin. It seems absurd, adding dead weight to a fighter jet, but it allowed them to retain the validated flight control laws of the Su-27 while still benefiting from the overall structural weight savings and lifespan increase provided by the composites. It's a classic engineering compromise, solving one problem only to create another that requires a brute force fix. When the J-11B finally entered service in large numbers, it changed the operational reality of the Western Pacific almost overnight. During the 1996 Taiwan Strait crisis, the PLF was essentially a non-factor. They didn't have the range or the sensors to challenge the U.S. Navy. By 2010, the J-11B was performing aggressive intercepts of U.S. surveillance aircraft. The most famous incident occurred in August 2014 when a J-11B pilot performed a barrel roll over a Navy P-8 Poseidon, bringing his aircraft within 20 feet of the American surveillance plane and showing off his belly-mounted missiles to the crew. It was a reckless Top Gun-style move that drew diplomatic condemnation, but it sent a clear message. The days of uncontested Western access to the Chinese coast were over. The J-11B provided the endurance to stay on station for hours and the sensors to find targets long before they saw the flanker coming. It turned the air defense identification zone from a theoretical concept into a daily, kinetic reality. The pilots flying these machines were no longer the ground-controlled robots of the Cold War era. They were flying golden helmet exercises, unscripted free-play dogfights where J-11Bs regularly trounced the older Su-27s. The difference wasn't the airframe, it was the situational awareness provided by the glass cockpit and the data link. Knowing what you now know about its performance and the risks China took with domestic engines, do you think the design approach was worth the years of reliability issues? Share your thoughts below. Critics often dismiss the J-11B as a copycat aircraft, but that's a superficial analysis that ignores the sheer engineering audacity required to pull this off. To reverse engineer the Su-27, the Chinese had to recreate the entire manufacturing ecosystem of a superpower. They had to build specialized jigs for the massive titanium wing spars, develop new types of radar-absorbent paint for the intake ducts to reduce the massive radar cross-section from 15 square meters down to a reported 310.5 square meters, and write millions of lines of code to get the fly-by-wire system to play nice with the new domestic flight control computers. If the flight control code was even slightly off, the inherently unstable flanker airframe would simply depart controlled flight. The fact that the J-11B flies at all is a testament to Chinese software engineering. The fact that it flies better than the original is a testament to their ambition. This was not IKEA furniture assembly. This was taking a Ferrari apart and building a better one using parts you made in your own garage. The J-11B also served as the essential bridge aircraft. It was the platform where China learned how to build a heavy twin-engine fighter, a skill set that directly led to the J-15, the carrier-based version, and the J-16, the sophisticated multi-role strike fighter. Without the painful lessons of the J-11B's WS-10 engine, there would be no J-20 stealth fighter today. It was the sacrificial lamb of the Chinese aerospace industry, the plane that took all the risks so that its successors could succeed. The PLAF eventually stopped buying the J-11B in favor of the even more capable J-16, which adds an AESA radar and a second seat for a weapons systems officer. But the B model remains the workhorse of the fleet. Hundreds are still in service, patrolling the South China Sea and the Himalayas, serving as a reminder that a well-executed copy can sometimes be more dangerous than a flawed original. When you compare the J-11B to its closest Western analog, the F-15C Eagle, the technical trade-offs become clear. The Eagle is a scalpel, refined, incredibly fast, and blessed with the world's best pilot training. The J-11B is more of a broadsword. It has more internal fuel, meaning it can loiter longer without a tanker, and its IRST, infrared search and track sensor, allows it to hunt for targets without turning on its own radar, a capability the F-15C only recently acquired via external pods. In a high-end fight, the J-11B's success would depend on whether its domestic electronic warfare suite could survive the onslaught of Western jamming. The Russians always struggled with microelectronics, and while China is much further ahead in that department, the black box nature of their EW systems remains one of the great unknowns of modern air combat. The J-11B's radar, the Type 1474, while an improvement over the Russian NRZ-1, is still a mechanically scanned array in its base form. This puts it at a disadvantage against modern AESA, active electronically scanned array, radars which scan instantaneously and are much harder to jam. There is also a dry irony in the fact that the J-11B's success actually ended up helping the Russian aviation industry in a roundabout way. Seeing how far the Chinese had pushed the flanker design, the Russian Air Force finally got the funding it needed to modernize its own fleet, leading to the Su-30SM and the Su-35S. It was a classic arms race, but this time the competition wasn't just between East and West, but between the original designer and the ambitious apprentice. The Kremlin realized that if they didn't start innovating, their best customer would not only stop buying their planes, but would start out exporting them. Indeed, the J-11B itself was never exported. China kept its best flanker derivative for itself. But the technology developed for it has found its way into various export packages offered to nations looking for an alternative to US or Russian hardware. The avionics architecture developed for the J-11B now informs the systems on the J-10C and the JF-17 Block 3, spreading the DNA of this unauthorized upgrade across the developing world. From a pilot's perspective, the J-11B is a demanding mistress. The flanker airframe is famous for its high alpha capability, meaning it can fly at extreme angles of attack where other planes would simply stall and fall out of the sky. But managing that energy while monitoring a modern digital cockpit and a domestic engine that might still have some temperamental tendencies requires a massive amount of cognitive load. PLAF pilots transitioned from the J-7, where they were basically passengers in a supersonic dart, to the J-11B, where they are managers of a complex multi-domain sensor platform. This shift in pilot culture is perhaps the J-11B's most enduring legacy. It forced the Chinese military to rethink how they train, how they use AWACS, and how they conduct long-range patrols far from their own shores. In the Golden Helmet exercises, J-11B pilots learned that having a better plane wasn't enough. They had to learn to use the data link to set up silent attacks, using the A-shoot-B guide tactics where one aircraft provides the targeting data while another launches the missile without ever turning on its own radar. Maintenance crews likely have a less romantic view of the aircraft. The use of composites and new domestic systems meant that the old Soviet-style maintenance manuals were useless. Ground crews had to be retrained from scratch to handle delicate electronics and composite repair techniques. The early reliability issues with the WS-10 engines also meant that J-11B squadrons were often working double shifts to keep a respectable number of aircraft mission ready. There's a certain bureaucratic humor in imagining a young Chinese mechanic looking at a blueprint designed in the 1980s in a Moscow suburb, trying to figure out why a piece of 21st century Chinese hardware isn't fitting correctly because the tolerance stacks are different. It's a marriage of two very different industrial philosophies, Soviet ruggedness versus modern precision, and like all such marriages, it had its share of screaming matches in the hangar. The logistical footprint of the J-11B is still heavy compared to a single-engine J-10, but the capability it brings, the sheer persistence and payload, makes the headache worthwhile for the PLAF commanders. Visually, there's something undeniably imposing about a flight of J-11Bs. They are massive aircraft, nearly 72 feet long with a 48-foot wingspan. When they sit on the ramp, they have a hunched, aggressive posture, like a cat ready to spring. The gray-on-gray air superiority camouflage used by the PLAF gives them a ghostly, utilitarian look that contrasts with the colorful, almost flamboyant schemes sometimes seen on Russian flankers. This is a tool of state power, not a showpiece. Every line of that airframe is a calculation of range versus drag, and every sensor represents a multi-billion-dollar investment in the idea that China can defend its own airspace without anyone's permission. The sound of a J-11B taking off in full afterburner, the WS-10s tearing the air apart, is the sound of a superpower that has arrived. As we look toward the future, the J-11B is beginning to show its age, but not in the way you might think. It isn't that the airframe is obsolete, it's that the J-11B proved the concept so thoroughly that it made itself redundant. The newer J-16 has taken over the high-end heavy fighter role, and the J-20 has taken over the stealth-air dominance role. This has left the J-11B in the position of the reliable utility fighter, the plane you send to intercept a P-8, to fly a routine patrol over the Senkaku Islands, or to act as an aggressor for younger pilots in J-10Cs. However, the story doesn't end there. There have been recent photos showing J-11Bs being upgraded to the J-11BG standard. These aircraft feature a new white radar dome indicating the installation of a modern AESA radar, likely derived from the J-16 program. This upgrade reportedly allows the J-11BG to carry the PL-15 missile, a weapon with a range exceeding 200 kilometers, and the PL-10 high off-bore sight dogfight missile. It's a testament to the fundamental soundness of the Sukhoi design that it can be endlessly tweaked, poked, and prodded into relevance. A 1980s airframe with 2000s composites and 2020s radar, the J-11BG is the ultimate expression of the platform's adaptability. The story of the J-11B is ultimately a story of national willpower. It would have been so much easier for China to just keep buying Su-27s and Su-30s from Russia. It would have been cheaper, the engines would have worked on day one, and they wouldn't have infuriated their primary strategic partner. But easy doesn't build a world-class aerospace industry. By choosing the hard path, by breaking the contract, reverse engineering the airframe, and insisting on a domestic engine despite the embarrassing failures, China transformed itself from a customer into a peer. They took one of the most iconic fighters of the 20th century and forcibly dragged it into the 21st. The J-11B is flawed. It was birthed in controversy, and its engines once had the lifespan of a housefly. But it is the aircraft that defined the modern PLAF. It is the machine that proved China could not only copy the best in the world, but could actually make it better. In the final assessment, the J-11B stands as a monumental achievement of industrial persistence. It represents the point where the Chinese aviation industry stopped being a collection of assembly plants and became a genuine center of innovation. While it may never have the clean sheet glamour of the J-20 stealth fighter, it was the necessary precursor, the heavy lifter that did the dirty work of maturing the technologies that define the modern air war in the Pacific. It proved that the flanker design was not a static relic of the Soviet Union, but a flexible, living platform capable of carrying the most advanced sensors and weapons that the modern digital age can produce. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching. The J-11B is more than just a copy. It is a declaration of independence in the most contested airspace on the planet. To look at a J-11B is to see the history of modern China written in titanium and carbon fiber, a story of taking what is available and refining it until it becomes something entirely new, entirely domestic, and entirely formidable. It is the swan that grew teeth, and the world of aviation will never be the same because of it.